I spent my life working in VSL doing post-tensioning in concrete. And now, for the first time, we test new material for this post-tensioning. And of course, this triggers a lot of excitement.
The origin of this project is that the wildlife on the border between the canton of Solothurn and Bern has been separated due to the construction of the national highway. And now with this new structure, these wildlives rejoin together.
The load on this bridge is super high. When we saw the load, we talk about the superimposed dead load, the load you add onto the bridge once the bridge is finished. And this includes the concrete, it includes the earth you put onto the concrete, it includes the trees, and all this additional dead load, which will load the bridge, making this wooden beam requiring additional strengths to carry these loads and therefore post-tensioning.
The wooden structure is actually spanning two spans, a small one which is not post-tensioned, and then the main span of 37 meters, which is post-tensioned going over the highway.
Also der Träger der Wildtierüberquerung besteht aus 3 Einzelquerschnitten. Die Vorgabe des Ingenieurs war, dass man Eichenklötze bei den Auflager hat. Und die einzelnen Querschnitte werden dann bearbeitet auf der Maschine vor dem Verleimen. Die Hüllrohre für das Vorspannsystem werden vor dem Verleimen eingelegt. Dann werden die 3 Träger aufeinander geleimt und in der Presse werden sie dann verpresst. Und nachher werden die Spannlitzen eingezogen und die erste Vorspannstufe wird im Zwischenlager aufgebracht.
We have done a partial pre-stressing on the pre-assembly yard just close outside from here. Then the beams with the post-tensioning system already installed in its final position. Then we stress the strands to final force, and subsequently we will have the concrete slab, the soil and the vegetation which will be done. From a functional point of view, the use of the post-tensioning is same independently if we talk about a concrete structure or a wooden structure. The challenge with wooden structures is actually to introduce the big post-tensioning force inside the wooden beam. So the solution which has been developed for this project is to have a big steel plate with many small individual anchorages which have actually 2 strands, and this allows to have a big area and a smooth load introduction into the wooden beam. This means as well that to guarantee the durability of the structure, we have a big protection cap, a special protection cap which covers the full anchorage zone, the full anchorage area.
The use of post-tensioning in a wooden bridge with a heavy duty application, has required a lot of tests. The program started by an initiative conducted by universities where the benefits of post-tensioning in wood has to be qualified, and indeed post-tensioning is increasing drastically the capacity of wood. As well for strengths, we can carry more loads with post-tensioning in wood, but as well for serviceability. When you post-tension wood, you can observe much less deformation of the structure under live load.
When you build a bridge in concrete, you are using a material that emits carbon dioxide during its production through the cement manufacturing process. And when you build a bridge in timber, you are using a material that absorbs carbon dioxide during this production process due to the photosynthesis of the trees when we produce the wood. So this is the main benefit for the carbon of a timber construction. The other advantage is that the timber structure is much lighter than the concrete structure for the same loads. So it requires much less energy to transport and to put in place.
You give a contribution to the environment, to help the climate change and to make a change in the mindset of the construction industry.